All right, everyone. So this episode is actually requested from some of our patrons, and they wanted us to talk a little bit about maintenance-related mishaps, right? A lot of times when we see mishaps, we hear it was the pilot's fault or it's some kind of environmental factor that led to it being the pilot's fault. But sometimes or another, it's caused by maintenance. I'm not exactly sure the exact statistic about how much of it is caused by maintenance, but that was something one of our patrons asked to do. So we're going to dive into two particular stories about some maintenance-related incidents. And thankfully for these two incidents we're going to talk about, no one was killed. And we kind of don't want to talk much about stuff where people actually die, or we don't want any incidents at all for that matter. But
yeah, not trying to get super grim on this, you know. These are just fortunate. These are ones where it was only asset damage and not personnel injury or loss of life. Right.
Or if there was injury, like it's
survivable.
It's survivable. I mean, they might have some, like, they're injuries that you know, they have a lasting effect, but they're not gonna kill you, or like you're confined to a wheelchair for the rest of your life. So one of the stories we're talking about, this was actually an F-16 that crashed in California in May of 2019. And the summary goes, on May 16, 2019, at around 3 p.m. local, a F-16 was flying, had a hydraulic failure, and then crashed into a warehouse about a few nautical miles, like less than like a 0.4 nautical miles away from the runway, which it was intended to land on. And it goes a little bit about the background of the plane. Like this was at a reserve base, and the aircraft that were in question, it was two of them, and they were practicing like alert drills, like you're on call. This is the signal you're gonna get when there's an emergency. So they're kind of like
the red phone rings, right? I've heard you mention the red phone before. Like that's the red phone rings.
Yep. Now, contrary to a lot of people believe, the red phone is not from the president. I mean, I'm sure there's a phone that's specifically for the president, for specific generals and commands and agencies and whatnot. But for almost every unit has an air code red phone. But that's more for like in case of emergencies, right? Like it only rings because of an emergency. Like there's no buttons, there's no dials. It's just a phone with a headset. And it's like one of those 1950 style red phones that light up when it rings. It's actually kind of cool when you see it, but like as far as a drill is concerned, but not in real life, that would actually kind of suck. But anyway, so the F-16 in question, there was two F-16s actually, and it was doing alert drills. And they got the call. They went through all their motions to actually get the drill going. Everything up to that point was spot on. Like the inspections were fine, the pre-flights were fine, the pilots executed their checklist fine, and the aircraft took off as expected. And the aircraft that actually crashed was the Dash 2, or the wingman of this two-plane section. They flew out to the training area. They did a couple of training missions and maneuvers here and there. And the whole time it was doing the training mission, they had no problems whatsoever. And then it was on their way back to base where they started having issues, where the mishap pilot in question started noticing a little bit of fluctuations in his hydraulic pressure. Sometimes it would be like plus or minus 100. And it's like, okay, whatever, that happens normally. Then plus or minus 1,000. Okay, that's terrible, but not too terrible. And then as he's getting closer to the base, now it starts spiking plus or minus 2,000. I'm like, oh, okay, that's not good. Now, for anyone who's never had any type of experience on a plane, plus or minus 2,000 anything is terrible. Terrible.
Yeah, that's pretty bad.
You know, I mean, most hydraulic pressure systems is probably like plus or minus 100. maybe 1,000, depending on the system and at what point in the system is being used. Right.
Yeah, I was going to say, I guess for me, I don't have really any fighter background, but to me, even plus or minus 100 sounds extreme.
Yeah.
I'm used to seeing like plus or minus 40 PSI. You know what I mean?
Right.
Like that's okay. We can manage that. 100, you start, returning to base or finding the nearest airport to land.
Right. And the good part was he was actually on his way to base when all this started happening. And then once he started seeing plus or minus 2,000, I'm like, oh, okay, we're having a problem here. So he starts radioing like, hey, he didn't call an emergency right off the bat. He's like, hey, I'm having some hydraulic problems. You guys might want to have a crash crew on standby just in case this stuff goes south, which is normal operating procedure for any flight, right? Because the second you call emergency, everyone starts flipping their wigs, right? Like, oh my God, what happened? They start already assuming the worst, like bad shit already happened versus like it's going to happen.
Yeah, but the minute you call the fire brigade to be on standby, that perks a lot of people up and gets their attention, and oftentimes a lot of unwanted attention.
Yes, a lot of unwanted attention. I mean, there are stories where MVP and we just called, what, I guess if you go by a color code system, like green is good, red is bad, it'd be kind of be like this code yellow-ish scenario. Mm-hmm. Just even like that little scenario, everyone starts flipping out. Like, why is there a code whatever? Why is there a yellow? Why are we in yellow phase? What is going on? Like, what crashed? What got hurt? Is everyone safe? And this and that. Like, oh, time out, man. Like, slow down. Let the situation develop before we start asking past tense questions,
Mm-hmm.
And so going back to this story, so like he's at plus or minus, he's like having pressure fluctuations about 2,000 PSI. And then he starts going through his checklist and he turns on the APU or the auxiliary power unit, which is standard procedure for most in-flight emergencies where you start losing hydraulic pressure or you start having hydraulic fluctuations. And normally when an APU kicks on, you're supposed to have a little bit of a spike on hydraulic pressure because it's introducing another element into the hydraulic system. But when he turned it on, it was like nothing. He had like no change in any of his gauges whatsoever. We're like, ooh, fuck, here we go. That's when he declared the in-flight emergency. He radios towers like, hey, my APU's on. I'm not getting any change in hydraulic pressure. It's still fluctuating or dropping. So, yeah, you might want to get standby guys up here in the near future, or like very quickly. And some airports, depending on the style of airplanes that are around, they have like an arrest cable, kind of like aircraft carriers. It's just so like the airplane can hit. It doesn't. I don't think F-16s have a tail hook or anything like that. But when they hit the arrest cable, it kind of slows it down, so any and all damage is confined to the runway and doesn't careen off into like the terminal and shit. So he calls it in-flight emergency. He figures out his APU is not working. And then he starts getting a little bit of a banking on his left. So he starts doing it's to his right. So he starts doing a little bit of stick movements to counteract that. And he's noticing with his inputs, the aircraft is still starting to pull to the right. So like none of his flight control inputs are registering to the aircraft. At that point, man, like that's like, oh fuck moment, Yep. I would consider like, well, I've officially shat my pants. If my uniform wasn't greenish brown, you would totally see like a giant brown stain around me right now.
Yeah.
At least I would. Fuck. If like you're jiggling, you're putting inputs in the stick, you're doing all kinds of stuff, and it's not working, it's not doing anything. Like, well, fuck. Well, this sucks. So what he does do is he has the landing gear down and his speed brakes on. So like if they do manage to land this thing, they can inspect it and see what went wrong. He was able to get the landing gear down. Everything's locked and his speed brakes are on and all that. But he's still having uncontrolled movements with the aircraft. And I want to say, what does it say? About 0.4 nautical miles from the runway, he loses all control. And he punches out. He punches out, and then the aircraft goes nose in into a warehouse. And it says at time of impact, the aircraft engine was still on, and a little impact fire occurred because of the crash. There were some minor injuries for the warehouse personnel that were around. I don't think it was because the aircraft hit him. I think it was just because from the sheer shock of the aircraft crashing into the warehouse. But the pilot was fine. Like, he ejected everything with the ejection or the egress system worked. He got kind of dragged a little bit from his parachute when it landed, but otherwise fine. It says from the damage just from the aircraft was about $24 million.
25 mil if you round up, and then 4 mil for the environmental damage,
right?
I.e. the mishap. It's the warehouse itself,
right? Now, can you imagine, man? Like, when just an aircraft crashing into anything, or even just hard landing on the deck, like, you got all sorts of fluids and hazardous materials that have to be cleaned up, and some of these, they have to be disposed of a certain way. So, $3 million for a hazmat cleanup and collateral damage cleanup sounds about right.
Yeah, actually sounds probably less than I was expecting. I mean, and also consider the cost is the way it is because there was no loss of life. I mean, this investigation would have gone on probably a lot longer than it did, and there'd probably be a few maintainers in Leavenworth had there been loss of life. You know what I mean?
Right. Absolutely. And especially for something as significant as a hydraulic failure. I don't know about most of you guys out there, but if, like, say I'm driving and I lose all control of the car, like as far as my inputs, my outputs and everything, I'd be shitting myself and I wouldn't know what the fuck to do. The fact that this pilot actually kept his composure and figured out how to punch out at least, that's a major accomplishment. And
yeah, it goes back to training, right?
Mm-hmm. Goes right back to training. And most pilots in any field they rehearse this stuff a lot. And in some cases, that's part of their certification. Like, what would you do in a situation like this? It would either be hydraulic failure, electrical failure, loss of flight control, or like you got a stuck accelerator, like you can't slow the engine down or some shit like that. You know what I mean? So when they actually cleaned it all up and they started doing the investigation for this thing, they found out that what caused the hydraulic failure was a servo actuator was sent to overhaul and depot maintenance. It was taken apart, it was cleaned, it was inspected good, and they put it back together. But when they installed it incorrectly. And that's what eventually led to it being to the hydraulic failure.
Loss of pressure.
Yes.
Yeah, so it says improper installation of 2 hydraulic check valves in the right flaperon integrated servo actuator.
Jesus. Now I can imagine when you're doing depot maintenance like this and you actually have to overhaul stuff, there's a lot of things in there that you can't inspect once it's put together. What's that? What's the word of it? Advanced stage of build. Like, once it's past a certain stage of build, there's really no way to check other than doing an operations check on it. And if the operations check, if depending on the intensity of the test, it may or may not indicate a failure. Right? So, like, okay, whatever, it works, it's fine. Move on. But I bet you, like, everyone involved in that process, they're probably like, oh, fuck, dude. Like,
so were these check valves? I'd have to read down through. I don't know if it says or not, but were these check valves, are those internal to the actual actuator? So when they sent them out for overhaul, the depot facility installed them backwards internally during the overhaul process, or were these check valves installed in reverse within the aircraft themselves? And then next question being, a lot of check valves, at least the ones that I've seen, they all have direction of flow arrows cast into the metal themselves, or at least a sticker that says direction of flow.
Okay.
I wonder if those were there. And then also, I find it very interesting that I know in a lot of aircraft design, it's either 2 different style fittings or 2 different sizes through the check valve, just to make it impossible to reverse. It's like the third fail safe or whatever. But I guess if it's, just normal check valve to shut off flow when the aircraft's sitting idle and off, I guess I can see those being the same size too. But yeah, just curious. I wonder if those imprints and stamps and stickers and all that were there.
So to answer your question, it goes, each actuator has an integrated check valve, which consists of a cap, a screw, threads, retaining ring, and an O-ring. A post-accident inspection revealed that the screw cap for the system A integrated check valve was not seated properly into the body of the valve. Upon removal, the screw cap from the system A integrated connection or check valve, the retainer was found to be permanently deformed, and the ends of the cap from the check valve were spread apart as depicted in the picture. So it was basically fucked up. It wasn't seated properly, and then with all that pressure running through it, basically fucked it up. And I guess like that flight was the final straw for that check valve to actually do its job.
Oh, how many flights did they have on it since installation?
Let's see. It had.
Trying to read through this article too. So for those who are listening, we are reading the investigation report that the Air Force, United States Air Force, put out about this. This report came out, I believe it was April of 2020.
Yeah, I don't think this is saying like how many hours it had since the overhaul, but it's basically saying like what caused it was there's within the check valve itself, there's like these caps that are installed inside it, and they weren't installed, not fully seated into the check valve itself. And then this kind of goes back to the advanced stage of builds. Like once it's in, you kind of can't tell if it's installed incorrectly until you test it. But if this was installed just good enough to pass like the visual inspection and the test, then like all's good, right? You can't tell other than intentionally trying to break it. But then again, like,
well, or were they seated and visually looked to be seated, but the minute you flowed hydro fluid through the check valve, it unseated those caps, and the caps got wedged sideways in the orifice there where they reside, and then partially blocking, which is why he had the fluctuations, right? Mm-hmm. As it's moving around, and it finally got itself wedged enough in there that, because I'm sure that system's probably running 3,000 plus PSI.
I mean, I'm sure when most hydraulic systems I know of usually run about 3,000 plus.
Yeah, so it either blocked the line or somehow fought out the system, right? If metal, whatever the material is made of, metal or whatever, and it blocked up the system, and fought out the hydro pump or whatever. But I wonder if it was there and it worked, and then after several cycles and pulling G's and all that kind of stuff, and then it just finally blocked the system enough to where a quarter of the fluid's getting through, and it's not enough to move the actuators under flight characteristics, under flight loads.
Right. Or what could have happened was like, since it's not fully seated, but it's wedged in there just enough, and then when it finally failed, right, the cap pops off, and then all that pressure just starts it just freely flowing with no amount of actual pressure to give it. And then just starts leaking, and all that starts giving itself its drop. And then that's what resulted in the crash. That's one way of putting it. We weren't there. We don't have the full analyses of it all. We only have like the report of what it said, like the summary of incident, and then what their findings were when they actually did figure out what's wrong.
So right here it says, it's just doing some more reading. Hydraulic pressure gauges and noted low pressure hydraulic system A, the aircraft's dual hydraulic system, initially noticed fluctuations between 1,500 and 2,000 psi, but as the flight progressed, the pressure fluctuated between 1,000 and 2,000 psi, and the normal operating pressure is 3,100 psi.
Jeez.
Yeah.
So it goes from, it's supposed to operate normally between 3,000 and 3,100, and then it drops to 1,000 to 900. Like, whoa, like we're having some problems.
But I was also noticing, this happened in California, right? And do you want to say where it happened? I mean, anybody can pull up the report, so it's not like we're...
Oh, yeah. So, like, this actually happened by March Air Force Base in California, in Riverside. So, weather could have possibly been a factor, too. Going from whatever their training area was to back in California, that could have been a fluctuation in weather. And that could
maybe, but typically we have pretty good weather out here. But it said the pilot initially noticed cockpit warnings or received cockpit warnings out over Palm Springs. So, initially, I guess one of my questions is why not emergency land in Palm Springs? I've worked at Palm Springs. I've seen fighters land there before. There's several other small airports around there. I mean, why not play it safe and just emergency land there, and then you're sending a road crew down to figure it out,
Yeah. For all we know, they could have probably done it, or he didn't notice all of it at that time, or he was just probably traveling that fast and he passed it before he had a chance to really analyze the gauges and stuff. Who knows, right? And the good part the pilot lived and probably lived to fly another day. It just sucks because A, you lost an aircraft, and B, you destroyed a building which potentially could have had a whole bunch of people in it.
Well, yeah, how fortunate that there was minimal or no people in there, and whoever was in there weren't in the middle of the warehouse. Like, I don't know if you guys have seen the pictures at all, but it's like 4 walls and no roof. Yeah. It was laid out over top of the warehouse and dropped straight in. Right. Just took out the whole roof, but left 4 walls. So fortunate that nobody was in the middle of the warehouse floor, at that time.
Yep.
So that's just very, very fortunate on that end.
Very fortunate. And the good part is like no human life was lost, which is the biggest thing. I mean, yeah, aircraft loss is terrible. Like, money wise, it's terrible. But let's be real, man. Like, having to answer for human lives is way more involved than explaining how you destroyed $24 million worth of an airplane. And this all goes back to show, like, since they found out that this was a maintenance related issue, like the check valves weren't installed correctly, that goes to show, like, all it takes is just a simple oversight, like from dotting an I to crossing a T, or just like, yeah, it's good enough. It can have such profound impacts, right? And and just going with the check valve, right? Oh, it's seated enough, it works, right? Or it passed the test, it works, right?
Well, so section 5 here of this report is maintenance, right? And the first thing they went to, we've said 100 times before, is forms and documentation. Mm-hmm. And they did a 30-day review of the 781s. And for those who don't know, the 781s are the forms to which the United States Air Force uses to document all maintenance being performed. And then they also have another system called IMDS, which is like the electronic database and the historical records for the aircraft. But they did a 30-day review of both of those systems and found no recurring issues. So kind of a one-off thing, right? If they go through and like, hey, there's been every other flight that somebody's writing up the Hydra system here, and every time you guys have wrote CND, what the hell's up with that,
Mm-hmm. Yeah, that goes back to a lot of stuff we've been talking about, where it says could not duplicate, no fault found, could not duplicate. That adds up, especially when it comes to an investigation. And this is exactly what we're talking about here. When MVP first mentioned it, like, the first thing they're going to look at is all the forms. Did you dot your I's, cross your T's? Did you sign off everything correctly? Any little thing is going to get nitpicked, and whoever was the person who originated that write-up is going to get quizzed fucked to no end.
Yep. That's why I say kill it with information, man. Put in there enough information that whoever reads that, even if they've never seen an aircraft in their life, they could read the work you did, understand it, and know what you performed that in accordance with, right? Yes. Like just always kill it with information. I will stand by that. That's how I was trained. I know not everybody does it, because I go through forms reviews now and I want to scream half the time because it looks like a 4-year-old did the inputs, and it's just, it's terrible. Like I said, if something happened, you know, with where I'm at work, I mean, I would go through the forms of like, you're all buried. You know what I mean? Mm-hmm. You're going to like, you didn't give me enough information. I can't determine if you did it right or wrong. Yeah, it's just bad news. So you gotta be savvy and squared away on your paperwork. Like I said, and I know Six has said it a whole bunch, and I've said it. But your documentation is literally half the job, if not more, because of redundancy issues and whatever else. But I mean, leave no gaps. Leave no gaps in the work that you've done.
Yep. And especially when it comes to something like an investigation, you did a job days, weeks, months ago, and then here comes the incident today, and they're starting to quiz fuck you on it. And like, well, fuck, I don't remember what I did today, and you want me to remember shit that I did days, months, weeks ago?
The only thing you have to fall back on is the forms and documentation. Right. That's it. That's all you have.
Right. And then say like, well, I followed the manuals and stuff. Like, where does it say that on your write-up? And yeah, you know, and sometimes, you know, some investigators are a little bit more enthusiastic than they should be because they're just trying to get to the truth. And sometimes they get a little cloudy as far as how they get that information. So sometimes, you know, they'll instigate doubt in yourself, right? And then just that little shade of doubt is all it takes. We're like, fuck, did I do that? You know, did I make sure I check everything right? Was it really leaking? Well, maybe that little thing right there, that's what caused it. Or that was an indication of it, right? And you start doubting every little thing you've done and every little thing that you potentially could or could not have done. And it just creates this whirlwind of anxiety for both of you, for the people doing the investigation and the ones being investigated. Like, fuck, did I? Right? And then say like what MVP was saying, like, if we're going to burn you because you didn't put enough information, so now you're in a sling thinking that you killed somebody or you broke something expensive. And then this thing releases, oh, it wasn't your guys' fault. It was way back at Depot. Someone just forgot to put a screw on or some shit. You know, the relief that the relief of guilt is gone, but all that shit that went through it up until you found it out, that's not going to go away. You know, like, oh, fuck, you know? Like,
yeah, I mean, I hope nobody out there has ever been under investigation, be it by the military or FAA or whatever your governing, flying authority is in the country you reside. But I can tell you, I've been under, and you know, being more experienced now and seeing other investigations go underway. But I was involved in one years ago. Probably only been in the industry 7 years at that time. So I've been in a decent amount, but never in an investigation. And mine was not a crash. The aircraft didn't even taxi. Something was discovered on a walk around, and man, they threw the red flags. They threw, you know, the air crew threw the red flags and all that stuff. And we got called up, and I was the last person to touch that bird the night before. Fortunately, you know, because I was the last person to touch it, I was immediately under investigation. And fortunately for me, the system that was under investigation was not a system I was called out to work on. But I only had the forms and documentation to back up that claim. Right. Mm-hmm. And so they had to research and go. Turns out the system that was in question had been worked on by another company 2 days prior in another location. And it was just noticed, you know, on this walk around by this air crew. So, again, fortunate. But like I said, you know, that's why you have to have excellent documentation, because it in many cases, like mine, that's the only thing that was saving me. Because I'm telling you, they were ready to burn me.
Mm-hmm. Absolutely. And again, the diligence of making sure you're doing the job right. Like, again, there's certain aspects of the job that get very boring, very tedious, very repetitive, and you kind of just get complacent with it, right? Like, oh, I don't need to grease this point, or I don't need to check this line because it's never bad, right? And then once you start falling into that mentality, that's when the shit happens, right? And then that's when they're going to start asking you like, well, did you check it? Or did you do this? Did you do XYZ? And then he's like, yeah, I did it. But you did it in such a way that wasn't very, not investigative. What the hell is the word? Like you weren't very thorough with it, right? You just kind of breezed through it because for all of your experience, it's never gone bad. It's never looked bad. It's never had a tendency to be bad. So like, whatever, it's fine. But this is the kind of stuff we mean. Like the simple little things, even the boring things can have such profound impacts. Now, does this mean like work through everything with a fine tooth comb? No. But just exercise some diligence. Like just make sure like if you're going through a checklist or if you're going through a procedure that you've thoroughly understood what you got to do and you have at least exercised a little bit of precaution and conciseness with your job to do it right. Because like you said, like when it comes down to the forms and you don't recollect everything that happened, you'll start having that shade of doubt. Like, fuck, did I?
Yeah. And that's a horrible place to be in. So let's see here. It says 4 months before the incident, the actuators were overhauled at Hill Air Force Base out in Utah. And then they just did on-site ops testing before returning to the actual aircraft itself. So they probably have a little test cell up there or whatever that they do. They hook it up and run it through the gambit. But it says here, due to the significant amount of hydrofluid in the accident from that right flapper on, they had to go and do further investigation. So it says the overhaul consists of disassembly, solvent wash, and inspection of parts for serviceability. Upon completion of inspection and appropriate parts replacement, was reassembled, sent for testing to validate operational integrity, and a series of automated tests run to ensure part reliability. So there we go, right? So we go like, well, did the guys install it and not op check it? Well, I'm sure they did, as the forms would indicate. But if you go even back to the depot level, there's additional checks in there. So sometimes these things don't show their heads till several actuations later or several flight hours later or whatever else. It's not always so immediate.
Mm-hmm.
Yeah. And they even go into the training of the overhaul technicians. Mm-hmm. So when you look at these investigations, right, like Six said, go, not saying go through with a super fine tooth comb, but know that it should have semi-fine teeth because the accident investigation board will be going through that with like blue whale teeth, that fine and close together, like nothing's going to get missed,
Right. It only goes in and doesn't come out.
Yeah. They're going to be digging into stuff that you won't even think of.
Right. And these are actual questions. Like, was this person trained to do this job? Is this his first time? Is this his fifth time? Is this his 500th time? Right. And then they start asking, they'll even go as far as asking, like, what's the background of the person, right? Like, how were you raised? Did you grow up with brothers and sisters? Shit like that. Like, this is a little bit extreme, but they can do that, right? And the reason why they do that is like, what was your mindset? They're trying to build that profile of what was your mindset at the time you did your job, right?
Right. They'll even look into it. Like for my specific instance, right? They looked into what my work life and personal life relationships were. They would dig into if I had any, did I have any beef with any coworkers, my boss, whoever, what, again, like Six said, what was the mindset when I came in that day? Did the wife and I get into a fight and I was just pissed off the whole time performing this maintenance that I actually didn't do, all that kind of stuff. It's like Six said, you'll start second guessing yourself going, did we have a fight? I know we couldn't decide on what we were going to eat that day. But I don't think it was a fight. It was just couldn't decide who wanted pizza and who wanted tacos,
Right.
But they will dig into all that. They will dig into all that stuff because they're also going, was there motivation behind what you did? Did you do this on purpose? This is sabotage.
Mm-hmm.
If it's deemed sabotage and everything else, like there's definitely going to be repercussions, i.e. minimal, probably losing your license. your A&P license, at least here in the States, that is.
Yep. And all that stuff gets flagged through whatever system that your aviation authority is. Like so-and-so had a major incident / accident on his or her record, and he or she was responsible. That is pretty much blacklisting you for a lot of shit, right? So again, with that one, this second story that we were talking about, it involves another military-style aircraft, and this one was probably it's very debatable if the incident was deliberate, not deliberate, but like they knew it could have happened, or if it was just like the weather was just really playing against them that day. And this one was a B-2 bomber in Anderson Air Force Base in Guam. So the incident goes like this: aircraft was about to taxi to do a flight, and then within seconds of it starting to roll out on the runway, it started to get like a air pressure fault, and then this thing starts careening. Like let's see, let me just read the summary of the accident. After engine start, the aircraft continued with aircraft checklist. The crew chief updated the weight and CG. The air data calibration procedures was designed to allow maintenance crews to correct any fluctuations, which there were none. When the air data was accomplished, the aircraft started to do its takeoff procedures. And then approximately 19 seconds after brake release, the master caution light illuminated with an FCS caution on the status display. Seconds later, the pilot in command observed associated air data faults with the system, and almost immediately the flight control fault indications went away, and everything suggested that it was fine. As the aircraft started to proceed through the takeoff, the air data system became fully operational as function and airspeed threshold and static logic. Let's see. When the nose wheel lifted off the deck, they initiated the takeoff procedures. The aircraft started to get, again, another airspeed fault. And then the aircraft started to go nose up. And the aircraft lifted off with the air data computations, and then started to lose its aircraft data with the airspeed and altitude indications lost, as well as longitudinal and directional stability of the plane were degraded. The aircraft goes tumbling back down onto the runway. So this goes into a whole different system. So we're talking hydraulic. Now we're talking about air data. So almost every aircraft in the world has like a air data system, which is usually with pitot-static system, where like air comes in, it registers a reading, and again it sends it to a computer, and the computer figures out or gives you indications of where you need to go and what you need to do. And some more advanced aircraft, it has a computer that calculates all those inputs for you, so you're not there doing inputs the entire flight, right? And this a pitot-static system also gives you your airspeed, your altitude, your ascent, your descent, your rate of ascent, descent, things of that nature.
And so just to let everyone know kind of how important that is for an aircraft to fly, the same thing happened when that one flight went into the river, a number of years ago in the wintertime. Was it New York, or I think it went to the river in New York. It took off out of JFK or something like that. They did a movie on it, but essentially the pitot-static system froze over. It was in the middle of winter, and so no air readings could be had. So oftentimes what will happen with these, when they're sitting in line waiting to take off, you're getting the jet blast of the one in front of you. So air crew will sometimes turn off the pitot-static heat and just let the hot air from the exhaust in front of you, keep everything melted off. And then they forgot to turn it back on, and everything froze over. So bad things happen. But, even like this one in Guam, though, I don't think anything has ever frozen in Guam. Mm-hmm. But it's still very much important to have pitot-statics clear, because even if you're in a high humidity location and I don't need my pitot-static heat here on the ground, if I forget to turn that on and I go to altitude, well, it will freeze at altitude if there's any moisture in there.
right? And it was the Hudson River, by the way. So yes, it was in New York.
There you go.
And it water landed in the Hudson River. I mean, kudos for them for even being able to water land like that. Most cases, anything that has to do with water landing, some bad shit is going to happen, right? Especially depending on how shallow the water landing is. This one in particular, when they did the investigation or the post-incident investigation, well, I'll back up a little bit. So when it did crash, both pilots were able to punch out. And one of them was...
You can punch out of a B-2?
Yeah. Yeah.
Really?
Yeah. Well, at least
I learned something new today.
Is what this article says. Like they punched out. The first pilot, he was fine, no injuries. The second one, he had his spine compressed because of the ejection seat. Now, anyone who's ever been a part of an egress of that nature can tell you that punching out of a plane is not a fun experience. And I want to say there's only so many times you can do an ejection seat egress because of two. Yeah. And the reason why it's two is because your spine can only take so much force. And then when that force is shooting you straight up, you're essentially compressing your spine into itself. And after the second one, you'll possibly sever some major important nerves in there and possibly die or be paralyzed for life, whichever comes first.
Yep.
But yeah, so pilots in B-2s can punch out, which is crazy. I didn't believe it myself until I read this article here. And then what caused the incident was exactly with the pitot-static, with the moisture. So Guam and any other Pacific island is very humid. And moisture builds up in any place it could find itself. And especially with the pitot-static system. Anyone who's ever worked with pitot-static systems or air data systems knows for a fact that you can't have moisture in the pitot-static system because all this stuff is pressurized. It's just like your brake system in your car. It's either all water or it's either all fluid or all air. It can't have both. And this is exactly what happens. So this thing's meant to have only air pressure. Moisture gets in, moisture accumulates. It fucks up the air data. It starts throwing faults. And in this one's case, the aircraft thinks it's not supposed to be where it is, or it's supposed to be higher than what it is. It goes nose up. It has fluctuation and then goes nose down. So, again, this just shows like the little things can lead to such profound impacts. Now, is there a whole lot of indication that you can tell if there's if the pitot-static system is dirty? Probably not, right? Other than the fluctuating air data.
Yeah, other than your fluctuating data that you're getting in there.
Right, which is why it's all so important. And pilots and ground crews alike always forget this, is putting the pitot-static covers when the aircraft is not in flight. Or vice versa, they forget to take it off when the aircraft's in flight. So is it going to do a whole lot? Probably not, but it's going to limit it. It's going to limit how much moisture gets into the system than just it being naked. So again, there's like the simple, most repetitive steps could have such, as boring as they are, they're there for a reason. Let's see here on the rest of this.
So what's interesting, back to the doc forms documentation, not all of their, everything was in compliance, except they did notice that not all red ball maintenance was input into the aircraft documentation. Only sometimes they were put in there. So that's another interesting. So for those who don't know, red balls, after engines start, typically the aircraft starting taxied out, it's sitting at the end of the runway ready for takeoff, and there's a warning light of some type, and you run down there to basically try to fix it on the spot so it can still take off and meet its mission, depending on the severity of whatever it is that they get their warning light from.
Yep. And so, just that little things. You think, this is no big deal. Like, we don't need to do a red ball inspection or red ball write-ups or end of runway inspections or write-ups. But these matter. And again, the inspection team, when they come in to do an investigation, they will nitpick everything. Everything. And again, like, these are very small but extreme maintenance failures. But it just shows, like, the littlest things could have the most impact. Heck, a paperclip can crash an airplane if you throw it in there just right. Now, that's kind of an exaggeration, but it can, right? I've seen aircraft suck up whole freaking geese and then they come out just fine. But
yeah, they didn't realize they ingested a goose. You know what I mean?
Yep. But a finely placed paperclip or a finely placed any kind of material or debris at the right place at the wrong time can turn into a fault incident or can lead to a significant systems failure, right? Depending on what the system is and what its redundancies are. Or something as even small as just clearing the bit on avionics equipment. Like if you don't clear the bit, then it's going to fuck itself up, right?
Mm-hmm.
So again, like we can't beat this up enough about just how like simple maintenance tasks, where no matter how small or repetitive or boring they may be, they can have some pretty mean consequences.
Yeah, I'll say one thing I'm kind of impressed with out of both of these articles is that nobody was found to have overdue training. Nobody was found to be doing improper work. Everything was properly documented, so to speak. None of that was found. I'm pretty impressed by that. Whoever is running the show for those two units definitely were on their people.
Yep. Right. And usually you hear some stuff like that, like, oh, this person, like he went to work drunk or he was under the influence of something, right? Or it was his first time doing a major task like this, something to that effect, right? Almost every other incident we knew of have something to that effect. Like the pilot didn't get enough sleep. The maintainer didn't get enough sleep. So-and-so was under the influence. So-and-so never been trained on this before. We hear a multitude of those, but these ones in particular, they're spot on. So other than the fact that a simple glance over of procedure or a glance over of a task slipped through the cracks, besides from that, they were pretty spot on, right? You can't just we can't blame down to the very minuscule about this is exactly your fault and you should be fired for this, because for all intents and purposes, anyone could have made these mistakes, right? Like there's many a times where like, oh, it's an air data fault, press to clear and it goes away. Oh, it's fine. Or like say a filter clog indicator pops, so just reset it back in, check next flight.
Yep.
Check next flight. If it doesn't pop, it's fine, right? But you never know if that one time you reset the pop, that was the one to really indicate a major fault. You just don't know, right? But and then for indications like that, you would have to refer to the manual as what is the next step. Like, okay, I resetted the filter pop, or I cleared the system, or whatever the case may be. What's the next step? And the next step says check next flight, whatever, check next flight, right? So, and if that flight so happens to be the incident, like, well, we found out real fast what that one's going to be. But as far as you're concerned, you followed procedures, all your documentation's in line, all your training's in line. You got no extenuating circumstance that could have led to you to make anything but the right decision at the time. Then there's really not much you can do.
Yeah, don't be afraid to question it either, right? If it's you the one signing it off, I know it's military can be difficult or whatever to say no due to ranks and all that kind of stuff and getting pressure, and you want to do a good job. But if you've noticed something where they're like, hey, just go ahead and, press to clear, and you're like, well, yeah, but this is the third instance in 2 weeks, maybe there's something more.
Mm-hmm.
No, just press to clear and move on. Like, cool, you sign that off, then I'm not signing that off. Right. And you could be threatened to lose rank and whatever else. But I was not prior military, so I don't know that pressure, but I would say I'd rather lose rank than be sitting in Leavenworth for two pilots who were killed due to negligence or poor maintenance or whatever, Right.
And sometimes you guys might hear something like, nothing stops operations, or nothing stops progression, nothing stops production, nothing stops manufacturing. Whatever, you've probably heard something along the combination of those words. When you hear something like that, that's when the black flags start coming out, red and black flags.
Red flags everywhere.
Like time out. No. First of all, that's wrong. And two, the procedures say to do XYZ and you're doing something completely different, we need to cease everything and take this up a notch. And if you're
cool. So we're going to go until someone gets hurt or someone gets injured or something is damaged. Awesome. Right on.
Right.
Thank God we're making forward progress though. Until then, to which all the progress that we air quotes made, we're now 45,000 steps behind. So awesome. Great.
Yep. And like MVP said, like, don't be afraid to question it. If something looks shady, you might make fun of because you brought up an issue, but hey, sometimes that little head scratcher could be the one that saves somebody's life. Or
you know what? And also, if you're getting that kind of pressure from whoever, and nobody in your own realm wants to back you up and they're telling you just to sign it off, I'd be like, okay, cool. And then I'd find your closest quality rep and just go, hey, I'm hearing and seeing some of this, and then let them run with it.
Mm-hmm. Or even your safety board, right? Depending on what it is. Quality assurance, safety, when it comes to something like that, like something very critical, they're almost hand in hand walking this down the line. Now, and they'll do their own reports and say, so-and-so said this and told me to go fuck myself. That when that gets documented on their side of the house, now they have a case, right? Now where that goes, who knows, right? And some agencies take that to certain levels of severity and to each their own process. But never be afraid to question it, even if it makes you look like the idiot. Like, it's better to call... I'm sorry, go ahead.
I was going to say, it's better to call knock it off and hold up and stop production and miss critical timelines than to be responsible for the guy who isn't on the floor with you anymore. He's in a wheelchair stuck at the desk doing paperwork for the rest of his life because nobody wanted to say stop.
Yes, absolutely.
Now, I don't want that on my conscience. I tell you that right now, like I it's bad enough getting calls in the night, hey, just this is going through the notification list here, letting you know we had an incident. Oh my God, what happened? Well, the door is broken. We can't open them. Oh, okay. Did anybody get hurt? Somebody stuck in the door? What happened? No, just the motor shit out. Oh, fair enough. Cool. Call facilities, move on.
Right.
I'd rather that, or they call and say, I come in the next day and say, we missed a mission because so-and-so said stop. Okay. Well, what was the situation? Well, you make them admit we were trying to do some shady shit and your people said no. Sounds good. What's the issue? Right. You know what I mean?
Mm-hmm.
Well, we can't stop production. Well, are we going to stop when somebody gets killed?
Right.
I bet you will then. Somebody's going to make you stop, and it's going to be way higher than me.
Right. It's either we stop on our own accord or CNN's going to tell us to stop,
Yeah. Or and now you're in jail.
Yes.
You know what I mean?
Yep.
What are we doing here?
Right. And then you guys hearing this wow, this sounds very extreme. It can be. It very well can be. So that's why it
can be super extreme.
Yeah. So it's one of those, you got to do what you got to do. You got to do what you need to do to make sure everything is T's crossed and I's dotted and all that. And the CYA yourself. Fuck. That's another big one. Well, any other further closing thoughts on this one, MVP?
No, I think we've kind of covered our ends of it. Again, we're fortunate with both of these articles and incidents that it was only asset damage and no personnel long-term injury or loss of life. It's bad when it happens, but trying to look at the silver linings to everything.
Mm-hmm.
Assets can be rebuilt or replaced. Personnel cannot.
Right. Absolutely. Now, if you're listening to this and you have a story of your own about a certain mechanical failure or missed maintenance procedure that led to a significant amount of damage or an incident, please let us know. Send us a line, shoot us a DM. Let us know one of these stories. If it's released, okay? If you guys can tell us this, right? Or if you got in such a way where it's something where it's a lesson learned that everyone should know about. That I should probably say that too. If it's a lesson learned that everyone can use, please by all means send us your story our way.
Let's put that out to the masses so everybody can be aware.
Yep. Do not plug in this thing this 3-phase prong into a 4-phased outlet. You know?
Right. Yeah.
That's extreme, but I'm just saying, you know, like one of those
Do
lessons.
not service oxygen system with nitrogen. Do not substitute hydro fluid for engine oil.
That one, it still blows my mind, man, because for one, they're two totally different colors.
I think about it all the time.
Like how do you mess that up?
Yeah, it's almost impressive.
Right. Again, send it if you got a story, send it to us. And on that note, everybody, thanks again for listening, and we'll catch you next time.
All right, see you, everyone.
Bye. We'd like to take this time to thank our patrons for supporting our show and allowing us to continue to make episodes, maintain our gear, and create merch for all of our listeners, with special thanks to Erica Lamont, Chris Hawkins, Ryan Frushauer, Dan Schubert, Jenny Dignan, and the ladies of the Dick Talk and Mimosas podcast. Thank you all so much for your support and patronage. Visit our shop at cancelformaintenance.com and grab some swag to show off both your support for us and your prowess as an aircraft technician. If you have ideas for the show or you'd like to be a guest on the show, visit our contact us section and send us a line. We will do what we can to get your ideas or yourself on the show. You can also follow us on social media, such as on Facebook at Cancel for Maintenance, Instagram at Canx, that's CANX for Maintenance Podcast, or on Twitter at CXMX Podcast. Check out some of our affiliates like Rockwell Time, where they make both rugged and classy watches to fit your lifestyle. Use the code CX4MX and save 10% off your purchase. Support us on Patreon. Our patrons get exclusive perks such as access to our Discord, discounts and early access to merch, special patron-only episodes, and so much more. Thank you again so much for listening, and we'll see you next time.